getting carried away there. So how are you doing? Hope you're having a good day so far. So do you want to know how to create your own virtual pet using a Raspberry Pi Pico and MicroPython? Then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to the keynote and start this show off proper, shall we? Okay, let me make sure everything is good there. I think we're all good. Okay. So, oops, jumping about there. So yes, this is all about how to build your own virtual pet. So you might have seen in the midweek video that I did last week, I showcased a 3D printed Tamagotchi-like robot. Obviously, it's not a Tamagotchi, that's a product copyrighted and branded. This is just a virtual pet, generic virtual pet, powered by Raspberry Pi Pico. So today we're going to be having a deep dive into the code and looking about how we put together something like this and how we can use these skills transferably to our robots. So you can see there, we've got some fun little icons, some graphics, and this is what really this show is all about, how we can animate these, how we can bring this to life. So we're going to be looking at the 3D printed design in the case, just very briefly. We're going to be looking at the user interface, how we can actually bring this to life with just 3 buttons. We're going to be looking at what virtual pet features we can have and make this a fun little toy. And then we'll be looking at the code itself. So we'll be looking at all the different classes, the structure of the code, some of the features, some of the nuances, and how to do things like animation using frame buffers. So a bit of a deep dive. Okay, so let's have a look at the design first, shall we? So the 3D printed case. So I designed this in Fusion 360, and the case is in 2 parts. So there's the top half and there's the bottom half. The top half has the cutout for the screen and the buttons. The bottom half houses the Raspberry Pi Pico and all the other bits and pieces. So there's a screen, which is the SSD 1306, and there's 3 tack buttons, which have just been soldered with the screen to some Vero board, which is just some circuit board with some little copper connections and all through the hole holes in it as well. So yes, that's what makes up the physicality of the thing. I can show you that now if I just go over to the main screen for a second. So like I said, it comes in 2 parts. So there is a front top, and then there's the back piece, and it has a little hole as well so that you can plug in your USB connector. So then there is a circuit board there which has just got the screen connected. And you can just see there, the screen has actually got 2 parts to it. It has like a top line and a bottom line. I think these screens were originally designed for like mobile phones back in the day before we all had Android and iPhones. You can see there we've got the 3 buttons. On this particular one, I've actually not wired up the buttons just yet. So what I've got over on the desk here is the prototype version. So I was just messing about with the screen there just before the show started. So let me just pull that off, put the other screen back in, and then we are ready to go. So let me just run the code and we can just see that quickly come to life. Oops, do I just need to run that again? I've not broken it ever, messing about with it. Let's see if that's going to run. If not, I will jump back. Let me have a look at that in a minute. So let's jump back to the keynote. So that's just my prototype version, which you can see there. Okay, let me just move that as well. Okay, so the virtual pet features that we're going to be looking at. So this is the interface. So it's made up of like a toolbar across the top. It has a skull, which means your energy or your health or your hunger is low. So if any of those 3 are low, or sorry, all 3 of those are low, you'll get the little skull sort of circling you, which means that you're going to die at some point if you don't address one of those 3 needs. Then in the middle we have the baby itself, which is our little chibi. And then we have some poop in the corner because he needed to go to the toilet. And then on the bottom of the device there, you can see we've got 3 buttons. We have button A, button B, and then we have button X, which is used to cancel commands. So typically button A will cycle through the menu, button B is like our select decision tool, and so on. But we could reuse these in any way we see fit. And 3 buttons seems about the right number to be able to use this quite well. Okay, so the graphics theory recap. We've touched on how to use the SSD 1306 before, but what I thought I'd do today is just give you a quick update or recap on how this thing works so that it makes sense in the code later on. Otherwise, it'll be a bit confusing when we see the code and we think what is actually going on behind the scenes. So what is a frame buffer? You might have heard this before. if you've ever done any kind of graphics programming before. So a frame buffer is just an area of memory used to store graphics data. So it's typically an area which is given in dimensions of like the width and the height, and that could be a single bit depth if it's just black and white. It could be 8 bits if you wanted 256 colours. If you wanted 16 million colours, then you'd need 3 bytes for each pixel. So because our Raspberry Pi Pico has a really small amount of memory, we're just going to be using a display that's black or white, which means we can actually store quite a lot. We can store 8 bits of information for every byte in memory. So it's quite an efficient use of the Raspberry Pi Pico's memory. So we're going to use a frame buffer to construct our scene, and then we're going to copy that frame buffer into the display memory. And you kind of do that all in one go, so you don't see any flickering of the display. You might see when I use the overhead camera, but that's just to do with the refresh cycles of the screen and the refresh of the CCD in the camera. But when I look at this, it looks like a solid display. So we won't see any flickering as we use this. And there are a technique that we use to actually copy bits across. We don't actually set each pixel one at a time. That would take too long on a display like this. So we've got a display that's got, I think it's 128. I've got one here actually, I can tell you what that is. So I think it's 128 by 64 pixels. So that's the entire size of the memory. And we can store 8 bits in a single byte. So we don't need too many bytes. You can probably do the math there to store a single frame for the screen. So what we're going to do is we're going to use a technique that's called bit blit, or blit, you might see it sometimes called. So in the OLED library for this display, you can blit a frame buffer into memory. And you can set where on the screen, in the screen's coordinates, you want to blit that. So if you've got a little sprite, a little icon, and you want to blit that to a particular part of X, Y, and Z coordinate on the screen, you can do that, and it will just copy those bits and pieces from the frame buffer to the main display. And blit is actually bit block transfer. So in computer graphics, a hardware feature that moves a rectangular block of bits from main memory to the display memory. And it speeds it up enormously by doing this, rather than copying it bit by bit, like I said. So on there we have a sprite, which is just a graphical element that's stored somewhere else in memory that we can move around on our frame buffer just by copying it by doing this bit blit. So it'll copy 8 bits at a time, which is very, very fast way of doing this. So how does it actually work? So if you did maths at high school, you might have come across truth tables. You certainly do these in computer science. And these also relate to some circuitry as well. So you might hear about AND gates and NOT gates, XOR gates, NAND, which is not AND, and so on. So the truth table is we have an A and a B input. So imagine on this, probably the easiest one to start with is the AND. So we have an A and a B input, and then we have the X as the output. So if we put nothing in, we get nothing out, because we have to have both of these set to actually get a result. So if A is set, so they say the top one's set and the bottom one isn't, that means that we still haven't got the condition where both are set, so we get a 0. If B is set and A is not set, we still get a 0. But if A and B are set, then we get the 1, we get the output we're after. Or is either of them, but not none. So if we say A and B are not switched on, we don't give a result. But for every other scenario, so if A's on, we say yes, you get a 1. If B's on, we say yes, you get a 1. If A or B are on, then you get a 1. Not simply just flips the bit. So we can use this NOT function to invert our pixels. So I've used this on this display to actually flip each of the bits so that it looks like it's inverted the image. So I use that in some of the code. And then XOR is like an OR, but instead of having, it's an exclusive OR. So it has to be one or the other, but not both and not none. So if we have 0 and 0, we don't get an output. If we have 1, A or B, we give a 1. If we have A and B, with XOR, you get a 0. And XOR is used when we do image masks. So if you wanted to sort of cut out a shape in your frame buffer that you wanted to copy the image to, then you could use a mask that says don't use any of these bits, but only copy that where there's a 1. So that's what you use the XOR for. But in our case, we're just going to use the OR. That's what the bit blit will do by default. So just needed to cover that off because that's how it actually works behind the scenes. And if you want to see this kind of in action, here's a series of bits in a byte. So we've got some 1s and some 0s in our A. Then in our B, which is going to be our frame buffer, we're going to or these together. So if either of these is a 1, we will get a 1 at the bottom. So you can see there, if either of them are 1 or both of them are 1, we still get a 1 because we're using the OR function. So that's how it kind of works behind the scenes. That function is part of the hardware, so it's very, very quick to happen. Okay, so let's go to animating some frames. So I was thinking about how we could make this more fun and actually to try and save some memory. So our Raspberry Pi Pico, I think it's 164K of RAM it has. It has quite a bit of RAM. It's either 164, 256, I can't remember. 264. Somebody can find out and tell me that. So anyway, it has a reasonable amount of memory, but not a whole deal of it. So if we start stacking up loads of frames in memory and we have loads of these and we have really complex animations, we're going to run out of memory. So when I was writing the code for this, I did have that scenario happen, and I've had to create some code that loads and unloads bits that are not being used into memory. And that made me think about, do I really need to have, so say I've got an animation where I jump and then I land. I only really need to store the frames where I'm going up, and then I just reverse the direction of the animation to make it go down. So I call that a bounce. So we're kind of going from A, B, C, and then B and A. And that means we save 2 frames out of that 5-frame sequence, and it just means there's a little less memory that we require. Whereas a regular, normal sequence would be, we just go from A to B to C, and then we're done. The animation's complete. A loop would be, as you would expect, you go A, B, C, A, B, C, A, B, C. And reverse will be you just start at the end and work backwards. So these are actually really simple to code. We can have a look at the code in a minute and see how that actually works, but it's actually very trivial to make that happen. And the bounce one is one that I use quite a bit, and literally our little baby robot does bounce around. So that's a fun use of that. So virtual pet graphics. I had so much fun creating these. Before we get into that, please make sure you like, comment and subscribe on this video. If you're watching on Facebook, give it a thumbs up. If you're watching on YouTube, give it a like. Drop me a comment as well if you're interested in doing anything like this, or you're interested in the animation side of it for your robot graphics. I'm thinking like robot faces and eyes and stuff could be used for this as well. And if you're looking at using this on a Raspberry Pi Pico or an ESP32 or perhaps microbit, let me know what you'd use this for as well. And just a reminder that we do go live every single, I go live every single Sunday at 7 p.m. British summertime or GMT, depending what time of year it is. I think it's just an hour plus at BST. So there'll be a video as we're doing now, live, and you can come and interact as part of the audience. And I will get to some of the comments that people are making down there as well. And if I also do a midweek video as well, I'll try and get a midweek pre-recorded video, usually around Wednesday, Thursday, Friday, depending on how complicated the build is. Cool. Okay, so let's get over to some icons. So I've chosen 2 sizes of icon for this project. The most common one I've used is 16 pixels by 16 pixels. So it's just 8 bytes. So the toolbar icons are 16 by 16. I've used a piece of software that's called GIMP. I'll show you that shortly. And that's like graphics or GNU image manipulation program, I think it means. It's kind of like Photoshop, but it enables us to save in this .pbm format. And PBM is something that Python can read very easily to grab the data and then put it into a frame buffer. So this is really, really good and free to be able to create our own graphics. And these, like it says there, easily opened by MicroPython when writing to the OLE display. So I've got 2 sizes. I've got the 16 pixel size, like this little skull down here, and I've also got the 48 by 48, just an arbitrary size I picked. The screens that I'm using, these little 1306 screens, they are very rectangular in size, so they've not got like a 16 by 9 aspect ratio. It's quite extreme really. It's almost like it's 2 squares side by side. And on the original virtual pet, that has like a very square screen. If you look at this, you might actually be able to see, if I just activate this for a second, you might actually be able to see that it also has a rectangular screen. You can just about make it out there. And then the top and bottom, there's these, they kind of cheat. They don't have a graphic being displayed there. This is an LCD, so they've got an image kind of burnt into the LCD, and they just sort of light it up and you see the shape of it. So it's not actually drawn with pixels, it's just illuminating that shape behind the screen. Only the middle bit is actually pixelated. So if I put that back there again, you can just see there's a little flashing icon on the bottom right there as well. So that was one of the reasons I was looking at 48 by 48. It's like if I've got 16 there and I've got 48 underneath that, then I've nearly reached the capacity of that size of screen, if not completely. Okay, so that's one of the graphics. The toolbar icons, so I've created 7 icons that seem to fit nicely on the screen, and it's not too far from the virtual pet I've based it on. So the first icon we've got is food. So food reduces hunger and makes our baby happy. So the hunger or energy will be increased as you feed it, and the happiness level variable will also be increased. The light bulb makes the baby go to sleep. I'll show you that in a minute. It's got some nice sleeping animation going on there. So that increases energy, increases happiness. There's a game which I've not implemented yet, so that'll increase health and happiness and reduce a bit of energy because you've got to move around. And first aid increases health. So the idea being if you leave your Pico-Tamachibi alone for too long, then it will get sick, especially if you leave it with some poop in the corner. So to solve that problem, there is a toilet button. If you press that, it will clean any poop from on the screen, which if you leave it on, it decreases happiness and health. Obviously, getting rid of that will stop that from happening, but it won't increase happiness. It'll just stop it from decreasing. The heart enables us to check on the status. So there's a sequence of 3 screens there for energy, happiness, and health. And then the last one, which is very similar to the one that's on the bottom right of here, which flashes when it needs attention. See, he's got that little skull there as well now. So that flashes when it needs attention. So the last thing to point out here on the toolbar is that there's a spacer between the icons. So I've made this a variable so we can actually increase the space or decrease the space between the icons. If they're all touching each other, you need to think about that when you're drawing the icon itself, and you've probably got less pixels to play with there. So I've given it, I think, 2 pixels between each 8-pixel cell. So the way that we actually cycle through this menu system is we press the A button to cycle through the icons, and each one of them will invert as you select them. We press B to select it, and then X to cancel and return to the main menu. Now I'm just going to try and see what was going on when I was just trying to get that to work. I think I've broken something there. Let me just check all my wires are plugged in and good to go. And that, let me just try running that code again. Let's see if that works. We should see it spring to life if everything's good. Oh no, what have I done? So it's not finding it on the... it has half done. Ah, maybe it's just... Maybe it just wasn't pushed in enough. I made a bit of a mistake by pulling it out while it was actually running. I don't think that was a good idea. There we go, it's running now. Oh no, and then it stopped again. Let me just pull that out and then push. In fact, that wasn't the one I was using. Was it that one? It might have been that one. It helps if you plug it into the correct connector, and let's try again. It's got to actually find it as well on the I2C bus. It's kind of working there. For some reason it's not displaying the whole piece. Let's try that one instead. And then one last go. There we go, perfect. Right, let me just see if I can get that any more zoomed in. Yeah, there we go. Okay, so I've got the little skull there, the baby. I'll start the code again so you can see what happens there. When I press run, so the code stopped there, the screen will stay as it is. So he does a little poop in the corner and then just sort of bounces about. And the skull's flicking his eyes open and closed. And I'm just going to press the buttons as well. I'll just zoom out so you can see me do that. So I've got 3 buttons just down here. If I just remove that widget. So these are wired up. So if I press this one, it will cycle through the menus. And what's happening there is inverting them. So now the reason the last one changes is because if we zoom in again on there, you can see that very last one is our call icon, and that's actually animated, so it's going between the top and the bottom. When I cycle through these, it will simply invert the graphic. Looks a little bit blurred there just because it's so bright. I think I'll probably change the brightness. Now if I press the B button, that will actually make something happen. So it fed it there. You could see like a little donut animates from the top. It goes into his mouth, and then it says energy +1. If I go to the light bulb, that will say night night, and then he's going to start doing some snoring. Now look at the speed of the animation, and look at the speed of the animation down here. So this is animating at one speed, and the Zs are animating at another speed. And I can also cycle through this while they're animating. And I'm going to show you how to do this, because I'll press the cancel button as well, just to show you that that goes back. I'm going to show you how we can get this animation to all work without it blocking the code. So normally when you write some code, you might actually block, as you're doing an animation, nothing else can happen. Now that's not really going to work very well with Virtual Pet. We need lots of things happening at the same time. So I'm going to show you in the code how we can actually do that. So that's a little demo. I'll come back to that and show you a bit more of it in a minute. What else have we got going on here? So yes, there's a couple of files that are on the Raspberry Pi Pico. So the first one is, I originally called it icons.py, and I've stuck with that. However, it's where I put all my classes. So all the clever bit of code which I use again and again is in this separate file. So the icons store the frame buffers that load the graphics file from the, it's not from the disk, but from the flash area of memory, the file system, into the actual frame buffer for that particular icon with a particular name, with a particular width, height, X and Y coordinates, and all the state that goes with that. That's all contained within the icons class. The toolbar class will load up as many icons that you want to provide it with, and again it can say which one is currently selected, whether it's inverted the graphic or not, return you the number of the selected item, and so on. And then there's one for the button. So I found this weird that MicroPython doesn't have like a button class already, yet you use tack switches quite a lot. So this simply just gives you a function where you can say, is button A pressed or not? And it just checks to see for whichever pin this is connected to, is that sort of 1 or 0. And then there's one that's called event, which I'm currently working on, which isn't quite finished yet. So the idea of this is you could set a timer. So say after 5 minutes an event occurs. So you could maybe take a poop in the corner, or say after 10 minutes he goes asleep if you've not touched or interacted with it in any way, that kind of thing. So it's all to do with timing. So that's the last one that's in that event. Then we've got the Pico-Tamachibi as well. So I call it Pico-Tamachibi, excuse me, because obviously it's based on a Raspberry Pi Pico. It's not a Tamagotchi. Apparently Tamog is egg. That's what that stands for in Japanese, I'm going to guess, because this is kind of an egg shape. And the chi, I think, is like, is it toy? Egg toy. So that's what this was originally called in Japanese, egg toy. So I've called it Pico-Tamachibi. A chibi is like one of those little manga graphics where they've got like a large head. So that's why it's called Pico-Tamachibi. That's where the main virtual pet code is. And then we've got a whole load of graphics files. So I will show you how I create them and how I've animated these. And then I've used this graphics image manipulation program, GIMP, to save them out as a PBM file. And then so it's PBM. So for example, eat01, eat02, eat03. That will be the frames that I will then animate. So I can load them up using my icons. My animation code, and you just give it the eat and it'll figure out the rest of them. It will actually just load up using the list dir function and grab all the files starting with and ending with a particular set of prefixes and suffixes, and then just load them into memory. So it's pretty clever like that. It'll just discover them itself. It is a bit of a pain to upload these one at a time when you're putting them onto the Pico first, but once they're on there, they're on there. Okay, then we've got what else have we got on there? So we've got one for the baby bouncing, so that animation of him sort of on screen just sort of bouncing about. There is one for him sleeping, which he's currently doing now. There is one which is just a still of the baby. There's a call animation, which is that sort of happy face, sad face, sort of flicking between the two. There's one where he eats, where the donut sort of comes down. That was probably the most complicated one to do. The first aid one, I think, is just an icon. I've not actually animated that. On the virtual pet that I base this on, there's like an injection thing, and I thought, don't really want to put an injection thing on there. I'll leave that alone, I think. A food one, we've seen that. Oh, it's just a food icon, that is. Game icon, the heart plus icon, the heart icon, the light bulb icon. the poop icon, and then the potty is the animation of him sort of bouncing into the corner, doing a poop, and then bouncing back. And then the skull just has, that's an animation, and it's just two cells, one with his eyes open and one with his eyes closed. And then the toilet is just the icon. And then finally we have the SSD 1306, which is a OLE driver library, which we looked at quite a while ago when we were doing the rotary display for the Raspberry Pi Pico. So we need to have all those bunch of files saved onto our Raspberry Pi Pico for this to work. Okay, so the icon class, let's do a bit of a deeper dive into this. So this touches on some of the things we talked about a little bit earlier in the show. So the first property, and when I say property, think it's a variable, whereas when we think about a method, that's like the function, the def. So we have a whole bunch of properties which are local to that particular class. And if that's not clear, we can touch on that later on. So let me know in the comments if you understand what classes are and you've used them and you're comfortable with them. If not, I can go over them in a little bit more detail as well. So image stores the frame buffer. That's got the image of, for example, the baby at the top there. That will have that particular grid of pixels for that. The X position is simply an integer that's set between 0 and 128. Y is between 0 and 64 as an integer, and that's just the X and Y position where you want this to be placed on screen. The invert is just a true and false. Excuse me. And then the width and the height are just what the width and the height of this particular frame buffer or sprite is. So is it 16 by 16 or 16 by 48 or whatever. Then the height is the name of the image. Excuse me. The height of the name, the name is the name of the image. We don't actually use this in anything. It's just useful when we're debugging it to sort of print out what the name is, so we can go, that's the thing that's got the problem. So that's all the properties for the icon class. Then we have the methods. So init is, with all classes, you have some kind of initialization, a constructor, which just sets up the class with some default values, maybe just some setting of things that need to be set. The image itself allows us to get or set the image property. So typically what we do in a class is we hide from the user of the class all our internal properties, and then we expose them through specific functions, usually with the same kind of name, and that protects the inner workings from the user, so they can inadvertently change stuff without us having declared this class, this function, and have it work on the variable itself. So what I mean by that is, say we had 8 colors and we wanted the user to choose one of these 8 colors. We could say that there's a color variable, but what happens if they just set the color variable to something that isn't one of those 8 colors? That would crash the code, and we'd have to make sure that we tell the user of that code not to do that. Whereas if we hide the color variable and then we expose a function which can get or set that color variable, we can actually have code in there that tests to see, is it within the 8 that is allowed or is it not, and if it's not, return an error message or just allow that to be passed back to the user, sort of saying it didn't work. So that's why we protect that. It's a good programming technique. It looks a bit over-engineered when you're going through something like just setting an X and a Y, but it's just good practice to do that. So we've got the X and the Y, we've got the invert, which is true or false. We can get or set the width, the height, and we can get and set the name. So that's all the methods that we need to look at for icon. It's quite a straightforward one. And then we've got the toolbar class. So the toolbar has an array of icons, so we can add to them using the add item or remove item. We have the frame buffer for the toolbar itself, so we can write that entire toolbar into the memory, the display memory. Then we have the spacer, which is that little gap between the pixels. It's just a variable that we can store how many spaces between it. So when we're actually writing out the icons to the toolbar frame buffer, we can specify how far apart they are. So that's what that does. The selected item returns back a pointer to the icon, so we can get at the image data and all that kind of stuff. Whereas the selected index is just a number, which one of the, from 0 onwards, which one of these have you currently got selected. So it's just like an internal counter for that. So then the methods, we've got the init one, which we always have. The reason it has that double underscore and then double underscore at the end of the name is just to make you understand that this is like a special function and not to be messed with. So this is part of the inner workings of how classes work, and that's why it has that special name. There's a couple of other ones as well. So if you're writing something that increments, decrements, is like, what's it called, a generator, then there's like a REPL, or a, is it REPL? What's it called when you iterate through it? There's an iter as well. So there's only a couple of them, but they're not to be messed with really. Then we have add item, which adds an icon to the toolbar. So we pass it a sort of a fully filled out icon class, and it will add that to its array. We can equally remove from the array. We just pass it the number of the item we want to remove. So I use that remove function, and the add one we use to add all the icons to the toolbar. The remove one, when I'm animating that happy face, sad face call icon, because that's animated, I was going to use this remove one for that, but in the end I thought it's actually easy just to write over the top of this, so we can do that. Data actually returns the entire frame buffer of the toolbar. Spacer is just setting that spacer value that we talked about before. Show will write the toolbar to the OLED display, so we can actually pass the OLED pointer to the memory area, and it will actually just overwrite it there. Select and unselect do what you'd expect. They can select or unselect an icon, and then selected item gets or sets the currently selected item. Okay. Richard's making some good points here. I'll come to them in a minute. And then the animate class. So this is one it's got quite a lot going on here. And this is the one I had to tweak quite a lot. I probably spent most of the time in this code. So the frames is an array of sprites, an array of icons, if you like. The current frame is whichever one we've currently got selected. So as we're animating through, so if you've got like 5 frames, the current frame is just which of those frames are you currently wanting to show. The speed. So when I was thinking about how can I speed up and slow down the animation without using the sleep command, because if I use sleep, that's a blocking command. That means the code will go down to the sleep and then it will wait for as many seconds as the sleep, microseconds you specify in the sleep. I didn't want to use that. So I kind of cheat on here. I just do like a NOP, a no operation. So the speed, well, when you specify a slow speed, it will just add some extra operations that do nothing to the animation. It just slows it down a bit. Whereas fast skips frames. So if you've got 5 frames, it might go 1, 3, 5, 1, 3, 5, rather than 1, 2, 3, 4, 5. And you can specify how fast you want it, how many frames to skip. And very slow is just more of them no operations. So we'll have a look at that in the code as well. The speed value just simply sets the actual value of the speed there, whereas speed is a string of like very slow, default, and so on. Done will say that the animation is completed, animating all the frames. So we've got 5 frames. After the 5th one, done will be set, and then nothing else will happen. The loop count is if we're making this loop through a certain number of times, how many times, what have we got left in there? So if we set that to 3, loop count will decrease every time it gets to the end, and so on. Bouncing is if we are playing the animation forward, so we're going A, B, C, D, E in the frames, or 1, 2, 3, 4, 5. When we get to the end, when we get to 5, it'll then go 4, 3, 2, 1. And when it's going the opposite direction, that just means that the animation is reversed, so bouncing becomes true. The animation type is it the loop, the bounce, the default, or the reverse animation type we're going to use, because there's different blocks of code to work on the frames. Pause will, the countdown, it pauses the countdown from the, it basically just stops it from doing anything further. It just skips through everything. Then set is just a general purpose flag. I found that I needed to be able to say set a value or not set it, so it's just a general purpose thing within this class that we can use in lots of different ways. We'll have a look at that in a minute. X and Y position on the screen, width and height, pretty self-explanatory. Now cached. So when I started building all these animations and stuffing this Raspberry Pi Pico's memory full of all these animations, I had an error that said could not allocate any more memory. So I'd ran out of any available memory. So I thought, well, when I animate something, so say when, I've not actually created this animation yet, but say when the baby's born, so there's like an egg that'll shake, crack, and then the baby will come out. I never need to have that animation again. So once I've displayed that, I can unload that from memory. So cached is just, is this file loaded into memory or not? So it's just a true or false, and it just helps with the memory management. So the loading and unloading, we'll have a look at that. And it simply is where we have the cache, where we have the array of all the frames, we can set that to none. But we do have to do a garbage collection. We just do gc.collect, which will collect that memory and make it available again. And then file name is the base name of the file images that we have in the sequence of for the animation. So if we have the eat animation, say that's got 5 frames, eat 01, eat 02, eat 03, eat 04, eat 05, the base file name is just eat. So that's what that's for. Next up, we have the methods for that animate class. Again, this is the biggest class that we have. So the get and set methods are the set, the speed, set, which is that general purpose flag, the speed, the animation type, the frame count, whether it's done or not, the width, the height, the file name. Loop and bounce are commands to actually make it loop or make it bounce. So although you can set the animation type to loop, you can also call loop with a parameter of how many times you want it to loop or how many times you want it to bounce. So you might say bounce 3 times and then you're done. We can also set the value, instead of it being like a positive number, if we set that to -1, I've made my code recognize that and basically continue the animation infinitely. So that's what's happening when the baby's just sort of bouncing or sleeping. It will infinitely do that until something else tells it to stop doing that. The functional methods, forwards, backwards, they just progress or regress 1 frame at a time. Again, maybe a little bit over-engineered. I thought that might be more complicated when I originally wrote this. So you could probably just write, because it's just a single line of code, it's just frame plus equals 1 or frame minus equals 1, current frame. Then we have load and unload. So load will look on the flash storage, the file system, and load up all the images that match the base name with the prefix of the base name and the suffix of .pbm. So any file that's got eat in it, it will load up in that sequence. Unload will just set that array to none. Animate will animate, and this is how we do that, different speeds of animation and how it can look so interactive while we're pressing the button and all the animations are carrying on. Animate will process 1 frame, and that's all it will do. It'll just, whatever the next frame is to do, it will process that based on our animation type and so on. If it's completed the animation, running animate will do nothing. So we just simply have in our code animate, and the code will loop and loop and loop and loop. So when it gets down there, it'll look like it's continuous animation, even though it can interact with all those other functions as well. Stop will simply just stop the animation, and we've got that init1 again, which just sets everything up to default values. Okay, so let's have a look what else we've got. So I'll just, before we get into the demo, which is the rest of the show, I want to show you some interesting things. So news. So we've simply hit 16,000 members in the Facebook, Small Robots Facebook group. So if you're not a part of the Small Robots Facebook group, get over there and become a member. And if you're a member of that Small Robots Facebook group and you haven't subscribed to this channel, so I've got 16,000 members in that channel, and I have, is it 2,600-ish, nearly 700 subscribers on YouTube. I'm setting a challenge. I want us to get to 10,000. It's a bit loud, that, isn't it? So yeah, what I want us to do is I want us to reach 10,000 subscribers on YouTube. So if you haven't subscribed and you're watching this, hit that subscribe button now. Help me get to 10,000 subscribers. And I'm hoping in years to come I'll look back and think, remember when I was trying to get to 10,000? So come on, be part of the solution there. Help me get to that. Okay, let's carry on with our with our keynote. Okay, I think we're nearly there at the code bit. Last piece of news is I've also launched just yesterday a new free course on SMARS learning, smarsfan.com/learn, which is a bringing SMARS to life with the Arduino. So a lot of people had asked, how do you bring a SMARS robot to life just with the standard Arduino using the motor shield and doing things like Bluetooth or line follow. So all the code is over there. And there was a few bugs, I think, on the SmileSFan website where people had tried to click on a link and it came up with a 404, and that's because I think I've moved files around in the background and it hadn't updated those links. So I fixed all them. If you have any issues with the website, go into the Small Robots group and let me know, and I will jump on that right away. But there's a new course for you to try out. So that's 5 we've got in total now. We've got the Robotics 101. We have Python 101, how to build a Smiles robot, how to build a Smiles quad robot, and how to bring that Smiles to life with Arduino code. Okay, I think it's time for some demo. Let us get over. So I'm just going to go over to the overhead again, and we can wake our little robot up here. So I'm just going to press, if I just zoom out a little bit, so you can just see the buttons there. Let's try and get it in a bit. There we go. That's good enough, I think. So if I press this first button now, it's just going to enable the menu to be selected. So if I press the cancel button, it will just cancel that icon, and then when I press select again, it starts at the beginning once again. So let's go to the very first one, which is the food one. And now we're going to press the B button, which is this one here. So he's going to wake up and he's going to eat the food, and he's going to get an extra energy point there as well. So he's bouncing about. Let's clear that poop off the screen by going over to the toilet one, pressing that, and that will clean it off the screen. So he's now just bouncing about. We can also go to the health thing, the heart. We can see health is 1, happiness is 2, and energy is 4, because we've been feeding him quite a bit. And that one there, I think there's a bit of a bug there. It shouldn't actually be calling at this point because it doesn't need our attention. And if we press that one again, that'll make him go to sleep. It says night night, and he's doing his sleeping again. So that's what we're aiming for. So this is all running on just off that little bread though you can see there. So we've got 3 buttons. They're just wired back to pins 4, 5, and 6, I think it is, or GPIOs 4, 5, and 6. We have the OLED display, so that's the data and the clock. So the green is the data, the white is the clock. So they go to the sort of right hand, oops, my hand's blocking out there. They go to that right hand, and the second to that there, you can just see it says SDA. We can zoom back in on that now to have a look. Just want to show you the wiring there. And then we've got ground and we have voltage. So that's just connected in turn to the voltage pin, which is on pin 5. It's 3 volts. And then we have that one there that's connected to the ground as well. So not very complicated setup. I've not included a speaker on here. I think that'll be the next improvement that I'd make onto this. Let me just zoom out and I'll show you as well. This is the half-built, more polished version than the prototype. So I haven't actually wired the buttons up yet. But you can see there it's just got the Raspberry Pi wired up in the exact same way, but these are actually soldered in now. And then the 3D printed case has got some little lugs for the Pico to sit on. And if we just put that in place, it does actually hold it quite nicely in place there. I just put that to there. And just to show you that this does actually work, if I unplug this and plug this into here, that way round, and I run the code again, let's see if this is going to work now. What am I missing? I don't think I've loaded all the animations on here because it's just giving me a bit of an error message. Typically, we can have a look at that in a minute though, but that one does actually work as well. Let's just put that back in there. And let's just run that code again. You'll see when it loads up, he bounces, does a poop in the corner, and then just sort of sits there. And he's got that skull next to him because his energy is at 1, his health is at 1, and his happiness is at 1. So he's not a very happy bunny. So if we change any of those settings, so if we did the food or we went to the medicine one, just give him some vitamins, then the death thing goes away. And again, we can just clear that poop by just doing that. Okay, let's have a look at the code itself then, shall we? So what I'll do, I'll bring up the full screen of the code so you can actually see. I'm just going to stop it running on the Pico. And here we go. Let me zoom in a little bit just so you've got an easier view of the screen. So let's just go to zoom in, which is that one there. That should be okay, I think. So I'm just going to hide the bottom section down there. In fact, we can just close it. go. And we can probably just move that out of the way a little bit. Okay. We don't need to see all those things just yet. So this is the main code. Let's have a look through this first, and then we can have a look back at some of the classes to understand what's going on there. So we bring in a bunch of libraries. So the first one we bring in is the machine, the I2C, because the display is an I2C device, and that needs a pin to connect it to. We have the library for that SSD display. So that one, I worked on that one previously. I think I'd found... Hey, Hybotics has become a member. Awesome. Thank you, Hybotics. I really appreciate the deal. Cool. So yes, that SSD library, I found one that kind of worked but wasn't quite what I wanted, so I tweaked it. So this is my own version of that library. It's pretty close, to be honest, to the original code, and I think we open that up, we can see who wrote that as well. But that's in the GitHub repository, which is in the description of this video. We then have my icons library, which I entirely created all by myself. And that has an animate, an icon, a toolbar, a button, and an event class that we bring in. We then bring in the sleep function from the time library. And we bring in the framebuffer library, which is built into MicroPython. And then there's also one that's called GC, which stands for garbage collection. I'm not entirely sure how that works. I understand that it does clear up any of the pointers, any of the memory that's currently being held onto. So when you create a function and you create some local variables, when that function is finished, those variables should be deallocated from memory, and that memory returned to the heap, so you can use that memory again. Now sometimes for speed they don't do that right away, and by calling this garbage collection.collect directly, you tell it to do it now. So I've included that in the code just to make sure things run smoothly, and it does appear to be running smoothly. Next up, we just set up the I2C device. So we have a data and a clock, which is on pin 0 and pin 1. And then we have the ID, which means on a Raspberry Pi Pico, you've got a bunch of I2C ports. I think there's at least 2. So it's either 1 or 0. Okay, then we create the I2C device. We set the ID to ID, SDA to SDA, and SCL to SCL. We then set up the OLE device. We say it's 128 pixels by 64, and then it uses the I2C device connected through that variable there. And then we call the init display, which just tells it to wipe anything that's in the current display memory. So then we've got our variables for health, happiness, and energy. If only life was as simple as that. Then we've got load the icons. So what we then do is icon is the class that's going to store the pixel, the sprite. So for example, the food, the knife and fork pixel. I keep calling it a pixel, the knife and fork icon sprite. So that's 16 by 16, and we're going to call that food. So we're giving it the full name so it can find that on the file system food.pbm. Now I did promise that I would show you how we create these graphics using GIMP. So let me just do that. I'm just going to load up GIMP. And there we go. Let me just go back over to the screen there as that loads up. Here we go. And it's very simple to create graphics in this. If I just go to File and New, and then I'm going to, instead of it being a HD image, we're going to say 16 by 16. It doesn't matter about the colour just yet. We'll just click OK, and we've got a teeny tiny little pixel grid thing there. So if I just zoom in a bit, let's make this a bit wider so we can see what we're doing. Let's zoom in a little bit more. And what we're going to do as well is we're going to go up to the image. We're going to set the mode to be indexed instead of RGB. And you can see there it's selected black and white 1-bit palette. So let's just say convert to that. And I've now simply got black or white as the colours I can select there. So if I just move that across so we can see it properly. So I can just draw, I don't know, a little graphic like so. And when I save that out, it will save it as, let's just save it as bubble, something like that. Let's save it in documents under MicroPython. And then under Pico-Tamachibi, and let's just call this bubble. And that's an XCF file, which is a format that GIMP uses for all its files. It can have layers and things like that. So if I just move out of the way over there, you can see there's like a layers area just here on the screen. And we don't need to bother about that. We just want to save this out as this PBM. So we go to export, and we then say we want to export as, let's click on this by file type. We scroll down till we find PBM, which is this format just here, PBM. So there we go, it's selected now. I click export. It will then say, do you want to save this as an as a RAW or an ASCII? So we want to save this as a RAW file. So I'm just going to click that. It's going to say, what do you want to call that file? And I can't see where that dialog box has gone, but it should be saving that out now to bubble.pbm. So let's just see, have we now got that file in our file system? Let's just go to there, which is our files indicator. And we should see that there's one that's called bubble and there's one that's called bubble.pbm. So if we click on that file, it will say it doesn't know how to open this. Do you want to open it anyway? Yes, we do. So it's going to say the built-in, which is fine. And you can see there's 4 lines of stuff. The first line is the version of the PBM file. So this is a version 4. It's been created by GIMP. It's a 16 by 16 grid of pixels, and then that funny question mark thing is the data. It can't show you this in the editor because it doesn't know how to handle this raw binary data, but that's what that is. So they're just the on and off pixels, black and white. So all we do when we want to load in the data is we just read in 4 lines and throw the first 3 away because we don't care about that. And we just know that this will contain 16 by 16 worth of pixels, and we can load that directly into our frame buffer. So let's go back to our icon, back to our Pico-Tamachibi. So when we pass food.pbm, that's just loading up that food icon. So let's just go over to, let's find documents. Let's just find the actual thing itself. So which way are these organized? By name. So we want the MicroPython. I need to tidy up my file system, I think. MicroPython, there it is. Then Pico-Tamachibi, which is there. And if we find the food.pbm, there you go. That's what it looks like. If I double click on that, does it try and load it up as, there we go, a little icon. I can zoom in on that. And that's what it looks like. Cool. So Adam's asking, can you create those files without the extra data and comments? No, that's just how they come. But it's 3 lines we just throw away. It really doesn't make a difference, to be honest, in the code. So I'll show you the icons code in a minute, how it actually loads that up, but it's very, very simple. And what we do there is we just load all the icons for the toolbar. So the food, the light bulb, the game, the first aid, the toilet, the hat, and call. They're all pretty much the same with, yeah, they're all 16 by 16, and they've just got the name of the file that we've called it there. We've then got a clear function that just clears the OLED display, just makes it all black. Animate will go through the frames, and for each frame it will just blit the frame to... Now I don't think I actually use that. I think this was my initial just testing stuff out. I bet we can actually just hide that away. Let's not look at that one. Building the toolbar. So we create a toolbar object we call toolbar with a lower t, and we use the toolbar with a capital T, which is our class name. And we create a toolbar object. We then set the spacer to 2 pixels, and then we add all those things that we've just loaded up into memory. We add them to the toolbar, and then we return that built toolbar. So TB is the built toolbar, so that just returns there. Again, maybe a bit over-engineered that, but hey. And then we've got a whole bunch of animated things. So Poopy, I was trying to think of the name. What do we call that, where it just goes and has a poo in the corner of the room? So we call the animate class. You can see there I've gone to the bother of putting some docustring stuff in there, and that's why you can see what's going on when I hover over it. So it says it's a class. There's a thing called frames, which you don't have to provide. It can figure that out itself, given the file name, the base file name. But you can provide that frames if you wanted to. The animation type is a string. So is this a normal, loop, bounds, reverse? If you don't provide one of them, that's fine as well. You can provide the X and the Y. Again, they're optional because we've not used them here. And also the width and the height are optional, but have provided them. And then the file name we have provided, which is poop. So what that will do is animate will go and find anything that's got the name poop. So if we go over to, let's just close that for a second and close our outline, we can have a look on the file system. There is 4 things called poop. So there's 4 animation things where the poop is sort of doing its smell thing. I think that's what, no, the 40, that's the one where he bounces, I think. No, I was right the first time. Poop is just the poo in the corner doing its little wavy thing. Potty is the one where he bounces, does a poop, and then bounces back. There's a few more frames in that. Yeah, there's, I think it's about 13 or 14 frames for that. That took a while to animate, because I'd literally just draw it out by pixels, load up that, save it as another one, move over by either dragging it or just redrawing it on GIMP. Yeah, so that took a little bit of a while to do. So baby is the little, our character who sort of bounces around on the screen. So there's just a couple for that. I think it's called Baby Bounce. So Baby Bounce is the name of the animation there. So we look in the file system, we can see there is 4 frames for making him bounce. And because I use the bounce type of animation, so if I close this file system thing, you can see the animation type there is bounce. So that means the 4 frames it'll go up and then it'll go back down again. So it literally is a bounce animation type. Eat is where he sort of looks up and the donut falls from the sky. And that's 48 by 16. No, sorry, that's the coordinates. I was thinking the height and the width, they're all 48 by 48 for the larger animations. The sleep, baby ZZZ, is where he sort of very slowly has the Zs. So you can see in there the animation type is loop. And then further down in the code, I'll actually set that to be very slow. The death is the bounce type. That's simply just 2 frames with him eyes open and eyes closed. And again, we set that to be a very slow animation so it doesn't look like he's flickering his eyes manically. Go potty is the one where he bounces to the corner, does the poop and comes back. And the call animate is the one where it flickers between the happy and sad face. One's filled in and one's not filled in. And then the call animate speed, I've set that to be very slow because I want that to be one of the slowest animation types. I then create 3 buttons, so A, B, and X, and they use the button class, and then we just pass in the pin number that they're connected to, so 4, 3, and 2. And then I've created some an index variable. We have the toolbar select index, so index just means which toolbar icon is currently selected, so we start up with 0, and 0 is just none or the very first one, I think. OLED is the name of our OLED display device. And Adam's asking a question there. Why does Poopy not have an animation type? So I've created some defaults in that underscore init underscore. If I don't provide an animation type, it'll just be the default one. So when he does a poop, sorry, not when he does a poop. When the poop is waving, there's only 3 frames, and it just happens that they can just carry on doing that ad infinitum anyway, until you tell it to disappear off the screen. So that simply defaults to be just play through it once, but then we call it again and it plays through again. Cool. So then we have a bunch of other Boolean variables. So cancel is false. These are all related to the toolbar. Feeding time is false. So sleep and death set equals true. So that death, whether we want to display them or not, I've used that set, which is my general purpose flag, to be true. So I've started out by saying I want him on screen to begin with. Really, that should be driven by the conditions. So if your health is low, that should be the thing that defines whether death is present or not. And that's where I need the next block of code is my work in progress. And this is these events. So I want to be able to say in a certain number of milliseconds or minutes or whatever, have this event call. So we can actually just skip over that and ignore that for now, because that's just a work in progress. Okay, so then we set the baby bounce, we set the poopy to bounce, and this is setting the animation type. So the baby will bounce, the poop will... You were just asking why don't we have an animation type. We could have just declared bounce in the when we originally called it, but I've actually called it down here and set it individually using our method. We then have the death, so the death loops a number of times. -1 means infinitely loop. The death speed is slow, so it's not very slow, but it is slow. The baby sleeping speed is very slow. The go potty loop is 1, so it only does it once and then stops, and then that's the animation complete. We set that to true, so when we very first run our code, he goes over and does a poop and then bounces back. And then we set the poop to appear on the screen to be false, so it only appears on the screen after he's done the poop thing. And then this go potty.load is I think some code further down. Is it further up? Do I actually use that? Oh no, sorry, what that is to do with. Originally I had these as blocks of code that I've actually removed from this code now, so you can't see them. I had a thing that would load up every single frame, and then I built out the animation class, so I didn't need to do that. And then this load means go and grab all those frames because we're about to display them on the screen, so that will load them into memory. So by default, they won't load into memory unless we tell it to do the load thing. And then the main block of code. So here we go. So if not cancel, so if we not hit the cancel button, then if we've not hit it, then unselect the index of the OLED. That's kind of, so if you've not cancelled it, in other words, just unselect it. If button A is pressed, that reads quite nicely, whereas that one doesn't. If button A is pressed, then set the index to be +1. So button A is our menu selecting button, so it'll just increase that menu until, well, it will keep increasing it as you press it, but then the next piece of code says if it's 7, which is more than the number of things on the screen, we have 7 icons on the screen. Trying to 7 icons on the screen, but they start at 0, so we will only really have the 6th one indexed. If we've got it to 7, we've kind of fallen off the end, and we need to reset the index and wrap it round. So what that means, if I just run the code and show you, and go to our split screen thing, I just pull this down a bit. So if I press button A, when it gets to the very nth one there, which is number 6, and I press it again, it wraps round and starts again. So that's what that actually means there. Okay, so that's that. Cancel is false because we haven't pressed the cancel button. If button X is pressed, then cancel becomes true, and we set the index to be -1, so nothing is selected. And -1 means if we then press the select button, it will then select, it will +1 to it, and that means it's the 0th one, which is the first one in our array. Oops, let me just lock that. Okay, so then we have, if not cancel, then TB select index OLED. Do you know what? I can't remember what that does. If not cancel, then select it. Right, yeah, that makes more sense now. So if we haven't selected any icon, then we make it so that it is selected. When we do toolbar.select, it also runs that invert thing, so it will flip the pixels from black to white, white to black, so it stands out more. And you can sort of see it do that. So if I just, again, flick back to there, when I cycle through there, you'll see they change colour, and it's simply inverting the pixels. So that's what's happening when we do the select function. Okay, if button B is pressed, now, if button B is pressed, that means we're actioning something. We're going to make it run whatever is currently selected. So if the toolbar selected item is food, then feeding time is true, sleeping is false, we wake up, and we unload baby because we're going to run the animation to eat the donut, and we don't need baby bouncing to be in memory at that point. So we can actually say unload it, which again just sets the array of those baby bouncing things to none and frees up the memory. If and once that's finished running that feeding time true, there's another bit of code further down that will load baby back up when that's finished. If the toolbar selected is game, then at the moment we don't do anything. That's where we're going to add some game functionality there. Not decided what that's going to be yet. Maybe like a little Flappy Bird type thing. If the selected item is toilet, then we pop up a message. So we set the toilet is of type event. An event has a couple of things. It enables you to have an icon, so it's like a dialog box in Windows or on a Mac. So we've got a little icon and we've got a message that we're going to display, and it will display that message for about 3 seconds and then wipe the OLED display because we call clear down there. So the message is going to be cleaning. We then say pop up and we pass in the OLED, which is the pointer to the display device, so it can print that to the screen. We then set poopy to be false, and we set baby to be true. And we also +1 to our happiness level because the toilet has been cleaned. If the selected item is light bulb and we are not sleeping, then we set sleeping to true. We then load up the baby ZZZ. We could actually unload baby there as well, but I've not done that. I could do that. We then set the sleep time message to be night night, and we display that message. Again, it defaults to that for 3 seconds, and then we clear that away. And I've said that I need to add an event that increases energy level after he's been sleeping for 1 minute, and I've not added that code yet. That's going to be part of that event code. And then we say sleeping equals false. Sorry, this is if he is sleeping. Sleeping now becomes equal to false because we've woken him up, and we unload the baby ZZZ, and we just print light bulb to the console just so that we know. And they're saying babies and poop go together great, don't they just? If the selected item is first aid, then we pop up the message vitamins, and we just +1 to the health and then clear the screen. Now this heart one is essentially just 3 status screens. So we display the message health equals, and then pass in the string of health. Health is just an integer. Remember we set that at the very top just to be equal to 1. And we need to wrap it in a string because if we don't, it'll say it can add an integer to a string. So we just have to cast it from an integer to a string, and just adding it just adds it to the end there as you'd expect. Then we just say heart status pop up OLED. So we're passing it the display, and it will display whatever message is currently in there. We then change that message to be happiness or happy. Happiness wouldn't fit, so I just had to do happy. We pass in the happiness value, and then we do the same. We pop it up for 3 seconds, and then we change the message to energy equals, and we pass in the energy as well. So Adam's saying, if the baby dies, will a tombstone added to the screen? Absolutely. If I had a buzzer, I would play a sad tune as well, but I've not done that just yet. Cool. So, and then the last one, call. So call doesn't actually do anything at the moment. Call animate OLED, call set equals true. Doesn't really do anything. Really, it's just a visual indicator. I probably should just set that to false, actually. Let's just do that. We don't need to animate it because... Oh no, we do actually need to... No, if that's selected, we don't need to animate it. That's kind of a bug at the moment. Time for poop. So poop check, poop event. None of that code's working at the moment. That's one of the events. Right, so that's all that if you're selecting something. And then the last block of code in our main loop checks for certain things to be true. So if it's feeding time, then we load up the eat. Remember, that's the donut falling into the mouth. We load that up. If eat's not done, then we animate the eat, and it will keep doing that until animate is done. If feeding time and eat done, then we set feeding time to false. So we've finished our feeding time, this means, in other words. We set the energy increase message to energy +1. We pop that up, and then we add 1 to our energy level. We then clear the screen, we unload baby eat, and we load up baby. There we go. If sleeping baby ZZZ animate, so that just means if we're sleeping, if the sleeping variable is set to true, then just animate 1 frame of the sleeping thing. Else, if baby is set, again, which is just this general purpose flag, if we've set this to be true, then baby is going to be loaded up. Baby is then going to be animated. If go potty is set, then we animate the go potty. If potty is done, then we say potty done. We clear the screen. Sorry, we set potty set to false. We set potty poopy to true. That draws a little poop icon in the corner. We load baby. We set bounce to be -1, which means just infinitely loop. I don't know why that's there. That doesn't really need to be there, to be honest. That's probably done elsewhere. And then we just say baby set equals true, which means just display the baby. And then there's some other things. So if the energy level is equal or less than 1, if the happiness is less than equal to 1, and health is less than equal to 1, so all those 3 things have to be true for this code to run, then we say death set equals true. Otherwise, death set equals false. So if you've made any of those greater than 1, then the death won't show. If the energy level or the happiness level or the health level is less than 1, then we set that call icon to be true because our baby needs some help in some way, but we don't know what help, That's for us to figure out. And then if the poopy is set, then we load the poopy animation, we animate it. If death is set, then we animate the death. Have I unloaded death at any point? I can't remember if I've done that. I've only just started introducing the memory management stuff, so we probably need to unload death after he's not true anymore. We show the toolbar, and then if the index is 6, which is the selected one, we display that. Otherwise, we run that call animate, which is the little call, the little happy face, sad face thing. We just animate that. Now, other than the places where we specifically provided the OLED thing, we don't call that anywhere else, just for efficiency, for speed. So the very bottom thing is that we display whatever we set in our frame buffer, we then write that to the screen. So all those things can be adding things to the OLED but not displaying them. It's just copying it to memory. And then only at the end do we say, right, now copy that to the actual screen that the user can see. And then I've got a sleep function. So there is a little sleep thing there. I can decrease the speed of that to make it run even faster if I'm not happy with the speed of the thing, but I'm quite happy with that level. So that is the main block of code. I'm aware it's about 8:15 now, so we can have a very quick look through some of the other code that we've got. We've looked at the graphics. So what we can do, what I find a better way of looking at things, if I load up this Explorer, you've got a couple of different things in Explorer. You've got whatever's open in these tabs here. So if you click that open, you can see all the files that you've got open. So I've got 3 files. So if I close Bubble, for example, over here, if I just X that out, you'll see that disappears from the open editor. The code that you've currently got selected will appear there. So if I go to icons, you'll see that change to icon, I think, if I click in there. And then outline gives you an outline of your code. So this is really useful. So if I just collapse all those things there, we can see that we've got 5 classes within our icons things. We've got the icon class, we have the toolbar class, animate, button, and event. So we look at the button one. This is one of the very simplest ones. So we call it class. So the convention is you have an uppercase letter for your classes that they start with. So B for button is uppercase, and this models our whether a button is pressed or not. So I can see that pressed is not used anywhere, because I can see that it's kind of grayed out a little bit compared to these. These are like highlighted blue, and this is sort of a dimmed blue, and that tells me that it's probably not used anywhere in the code. The pin number stores the pin number of the button, and whether the button is down is true or false. So when we initialize it, we set up the button, we just create a pin from the machine. We say it's a pin in and it's a pull down. That's just the ones that work for me. And then we set pressed equals false, which is that one up there, even though we don't use that. We've then created this is called a decorator, this at property, and that means we're going to treat this differently than a regular function. So when you call a normal function, you have to have the brackets at the end. When you set it to a property, you don't. So you can just say is pressed. You can just say, if you create an instance of this class, we called it button A, you can do button A dot is pressed, and you can use that in like an if statement. If button A dot is pressed equals true or equals false, then do something. Otherwise, you'd have to have the brackets on. The self bit just means refer to this set of variables here. So that's what self does. So if we say self underscore underscore pin, we're looking at this particular pin for this instance of this button. So that's what that does. Why they have to include self and not just make it know that you're referring to those in the class, I don't know, but that's just the way it works. Great, we've got a new subscriber. Wayne has joined the channel, which is awesome. Okay, then we have if the button is false, then we return false. If the button is true, then we return true. We've got a little bit of debounce in here as well. So this just means if you pressed it down and you hold it down and you keep checking, it isn't going to fire lots of different events, basically. It just returns true or false. So that's the button one. That's probably the easiest one. Let's have a look at the icon one. So this has got a couple of private local variables. It just sets them up. So X and Y just set to 0. The image is set to none. It's not inverted. And we just give it an empty name. And then when we initialize it, we can decide this $none means it's optional. We don't have to provide that. And basically everything is optional. So we can just create an icon with no data provided and then set them individually later on. So if the width is provided, then we can set our internal width to be whatever the user's provided, and so on for all other variables. If the file name is not none, then we can set the load icon. We can load the icons using, so load icon is a function a bit further down. I'll just keep scrolling, I'll find it in a second. There it is. And what it will do is it will open a file with the file name that we passed in. So it will then do 3 read lines. Remember the magic number, the creator comments, and the dimensions. We don't care about them. We read them in and we just ignore them. And then we set the data to be equal to a byte array, because it's an array of bytes. And we read in that block of funny question mark things that we saw before. And that's the data that we want to display. Then what we do is we create a frame buffer. So a frame buffer is from that frame buffer library that we brought in. We pass in that data as the first parameter. So if I click on here, I think we might be able to see, we basically just need the frame buffer data, an X and a Y. So we have, a width and a height, sorry, width and a height. And then the last bit, mono HLSB. So when we're looking at our data as a pixel grid, is the data horizontal or is the data vertical? Because some different graphics formats store things vertically. The way our OLED display devices work, they have an X and a Y starting at the top. So this mono HLSB just means it's black and white and it's horizontal rows of data. So when it's reading the number of bytes that it is wide, it will then assume it's the next row down. So that's what happens there. And then we just return that frame buffer that's just been built from that file that's been opened. So load icons will just take a single file based on that file name and load it up. Now I want to show you in the animate one, I just want to jump to there for a second. And I want to show you when we pass in, when we load up an icon. So let me just find the load function. Let's just find, there we go. So when we want to load in an icon, we already know what the base name is. So eat was an example. So if it's not cached, that means we have to load up the file because we haven't already got it in memory. Files equals list dir. So that will list the directory. It'll get a list of all the files that are in the current working directory. In fact, we can stop our code. We can do import os, and we can do os.listdir like this. And what we get there is a list of all the files that are in the current folder. So you can see there a whole bunch of files. Now what we want to do is we want to filter that list of all them files that we just loaded up. We create a blank array. We then say for each file in that files array, if it starts with the base name, so eat was the one I was looking at, and ends with .pbm, then we append that file to our array. And that will build up for however many files we've got, whatever they're called. It will basically just create a new icon with the file name of file, with the width as the width that we've currently got, whatever that's set, the X and the Y and the name, and it will just append that to that array that we've just created there. And that's it. So that will build up and load into memory all the file animation frames for that particular thing. So that's what load does. Unload simply just says cached equals false and frames equals none. So it just erases that. All those pointers to things just get taken away. And then we've got this GC, which is garbage collect. So we say garbage collect, just do your housework at this point because we're freeing up the memory. And then the animate one is, depending on what the type of animation is, it will then do various different things. So there's lots of different logic in there for incrementing or decrementing, depending if you're at the beginning or at the end of the animation of frames. And the way that we know if we're at the end or not is because we use the length. So let me find the variable frame count. I've created an internal property called frame count. So let me just find frame count in here because frame count is actually a property. There we go. So frame count is a property, which means we don't need to use the brackets at the end, but it is actually a function. And what it returns is the length of the current array of frames minus 1. So the reason we do minus 1 is because the length will be starting from 1, I think, and we want it to be shifted to the left because we start counting at 0. I think that's correct. Yeah, so if there was like 4 items in there, it would return 4, and actually we want it to be 3. Anyway, so that's what frame count actually does. There's no way of setting the frame count. It's just something it figures out from the frames array. So let's so that's a very quick tour of some of the major classes that are in there. There's quite a lot going on there, but I'm aware that we're an hour 25 into the show now. So I'm going to look to the comments. If you've got anything that you would like to look at in this code, let me know. Just put a Q in front of your question so I can find it easier in the comments. And I'll just scroll back now to the beginning of the comments and just see what all you guys have been talking about while we've been on the show. So Dix BTW, I've not seen you on the show before. You're on Twitch. Hey, what's going on? We have Hypotics. I think it's Dale. So he's saying it's going to hide from the evil poop. And he was saying yes, poop and babies definitely go together. And Adam was saying, when a baby dies, is a tombstone going to be added to the screen? Yes. Now I believe on the original Tamagotchis, a baby couldn't die because they really thought through, you know, the mind of a consumer. When you bought one of these, you're probably going to be really intensively looking after this, probably for the first day, and then you'll probably forget about it. So they've made it so it can't die whilst it's a baby, and whilst it's it will eventually evolve into different types of creature depending on how you treat it. So if you discipline it correctly, it'll become a particular type of Tamagotchi. If you don't discipline it and it's an evil one, it'll become a different type. And there's about 16 different types, I believe. So you can cast poop at Adam Bryant if you want. Cool. So, and there he's literally throwing some poop at him. Nice. Yep. Yeah, I think you have to choose your words carefully because I think there are some filters on YouTube. I'm not sure about Facebook and Twitch and Twitter. They might be a bit more friendly, but I think you get booted off if you use bad language on there. So Dale said, I've now got poop on my mind all day. Thank you for that. It's a pleasure. No problem. So apparently the icon was designed as a chocolate ice cream, but everybody called it a poop. I'm not sure I believe that. Is that true? Random thought though. Baby Grim Reaper. I know, how cool is that little icon for the little death thing? Just a bit creepy that, but it's on the real one. So I've got one here. This isn't a Tamagotchi. This is just like a £5. You can see him just hovering over there. So they've got an LCD display here. It's not an OLED display, so it isn't backlit like the one that we have. So this one is backlit, and therefore it's very bright. Now what I was trying to demonstrate before, this is actually a black and white display. My horrible fingernail there. This is actually a black and white display, but it has 2 different coloured gels over the top to make it look like it's 2 colours. So there's like a yellow bit and a blue bit. And I think they were originally designed for like a mobile phone, so you had like the battery and the cell strength on the top there, and then you would have like all the caller ID and all that kind of stuff on the bottom section. And you can, if you get the light just right on these, you can actually see. Oops, try and get one without throwing it on the floor. See if I can get one that's on the main screen here. I'll just peel off that so we can see it. If I get the light just right on this, you can actually see. I have to hide my face so it doesn't find it. Might not be able to get this in focus just right, but you can actually see that there's like a line of pixels missing. Come on, focus. There's about, no, I don't think you can see it on there. Hey-oh, I'm just trying to show that. But when you write a full pixel image to the screen, you can see there's like a hairline, almost like a crack. So what else did it say? So hypothesis, it did not announce me when I joined a bit ago. I saw that flash up on the screen. Yeah, I think it did. He's going to look at our comments. Yes, yes. And Ravi says, that's very kind. I was following your videos, felt your videos very underrated. I'll get that out. Underrated. Oh, that's very kind. I'm hoping to grow the channel, so I need more people to comment on the stream, more people to like it, and so on. And that tells the YouTube algorithm that you guys are really enjoying this, and therefore show it to more people. So yes, remember the funerals being held for Tamagotchis? Yeah, they were all the rage, weren't they, in the like 90s and so on. I remember I had a proper one, and I kept it alive for a while. And then these ones. So what I was fascinated with this, look at the speed of the animation on this. It's really slow. And I think that's because they're actually loading and unloading frames from flash storage, because the actual RAM of that device is really limited. Because, you know, this isn't running a Raspberry Pi Pico. This is running like probably a special system on a chip thing. Hey, we've got Camillo in the house. How you doing, Camillo? Hope you're having a good time. I've got my my two bots here. That's the new one. He's not actually been constructed properly yet. He's literally just sat on his legs. Legs haven't got any things in, but this one's constructed. So Auto DIY in the house. And yeah, Ravi's saying a great teacher. That's very kind. Thank you for that. And Camillo says, very excited for this live session. I've always wanted to do a Tamagotchi version of Otto. Absolutely. So where I was going with this is sometimes you've got to work on little projects that just stretch your skills that little bit further than they have before. So me building animation classes and figuring out like bounce animations and stuff, I've now got that code ready to go for anything else I use. And I was thinking, you know, Amazon have built that new robot that's essentially just like a wheeled robot with a flat screen that can move with eyes on the front. I'm thinking maybe we get a bunch of these displays, you know, like so on the front of a Smars robot. Let's just grab a Smars robot here. Oops. And yeah, we just put these on the front and have a little face on there, and maybe have a servo so it can sort of tilt up and down and so on. So that's kind of what I'm thinking. We could do that. Cool. So no questions from anybody else. Right, I think we're probably time to wrap the show up then. So let me just make sure I've covered everything I wanted to cover off. I think I have done. So just remember again, 10,000 challenge. We're going to try and hit that 10,000 subscriber limit on YouTube, but I need your help to do that. Like the way the sound cuts dead there. I need your help to do that. So if you're watching this and you haven't subscribed and you're on the fence, it doesn't cost you anything. Just click that button. It really helps me out on the channel, and we can share more robot stuff to more people. So yes, the Hypotic says that's what we need. Truly mobile Alexa, not. Great stuff. Well, thank you all for watching. Really appreciated you joining me on the stream today. And I have actually lined up another guest for, I think it's the 17th, is that right? Yeah, 17th of October. So not next Sunday, the Sunday after. And that's Simon Monk from Monk Makes. So he's running a couple of competitions at the moment. I think you can get your hands on some of his stuff, some of the microbit stuff from the store. So that's worth checking out. And he's also got a new book out as well about the Raspberry Pi Pico. So I can't wait to get him on the show as well. I've actually bought a number of his books in my little bookshelf that I've got up there. Without even knowing who he was, I'd bought these. I think I've got like the Arduino evil scientist book or something. I'll get them all out for the show. But he doesn't live too far from me, actually. He's quite local, probably only about 20 minutes away, something like that. So yes, cool. So thank you everybody for watching. I really enjoyed you stopping by and sharing your time with me, and I shall see you next time. So thanks for watching. Subscribe. Catch you later. Thanks for now. Bye.